third data science seminar series. We are lucky today to have Professor Uku with us, who's going to talk about generative AI and kind of how he sees it playing out in the future. For those of you that are joining us a little bit later, again, I just always want to emphasize, we really try to make these sessions, we don't want you to just, be sitting there and just listening. We want you to feel as though you're able to interact with me, with our professor. So if you're able, feel free, turn on the camera. There'll be time for Q&A. We want this to be as collaborative and as engaging as possible. And there's also the QA box in your Zoom, and then also the chat feature as well. So if questions come up, we'll try our best to answer those questions if they're relative to the slides. But I'm going to stop talking and hand it over to Professor Uku, who's going to go through today's presentation. Professor?
Hello. Corinne, you have a question? You raise your hand. Okay, I think we're good. Well, welcome everybody. We created an insight session around the Gen AI today. So what we were going to be doing is, I'll try to explain the fundamentals. I want to be informative as much as I can. First, let's understand how does it work without going too deep, so everyone can take notes or ask questions whenever they want. Then I want to focus on the current business applications, responsibility around it, and operating outputs, so we can discuss further. Okay. Let me put the chat on the right. Oh, we can have this. All right. So I have a question. Do we know let's start with data. Everything started with data. Structured data, semi-structured data, unstructured data. If we can think of that, a massive change happened in the early 2000s because of this variety of data. Like we are so used to work in Excel spreadsheets, relational database, and very organized and well-managed data sources. But after the semi-structured and unstructured data came, is not in the very familiar form that we are used to, but like the images, text, audio, key value pair data. This was something different to process, because when we got for example, a text or image, I'm not able to get the mean or standard deviation on an Excel spreadsheet. I needed more deeper understanding to extract the value from these unstructured and semi-structured data set. And if you look at today's numbers, only 10% of the data is readily available for us to do the processing. And most of the data is untapped in unstructured format. That's where the AI started to gain a lot of attraction, that how we can get better use of this massive data that currently we are not capitalizing. Especially after 2010, most of the machine learning and AI field focused on understanding the deeper connections within this unstructured data and to create business value for our professional environments. And here is the little design template matrix. I'll just go very simple to explain. I call it machine learning matrix, and what we were doing before the generative AI, and then what has changed. As you all know, familiar with this, we have this design matrix that we have the features, it defines how many dimensions we have, and then we are trying to predict something as an output column based on using the association between these features and this output column. Like, for example, a fraud detection case in a financial service. What do we have? We have all the features: amount, date, risk score, location, or other features. Sometimes the size of this feature set could be millions. And then we are asking from archival data, hey, look at these features and look at the labels and try to learn from this yellow matrix. Then once you learn enough, then you can actually predict new unseen data if it's a fraud transaction or not. Most of the supervised, we call it supervised because it's getting supervision from this output column. Applications are today we adopted in our companies. For example, you can use ads and user logs as the input features, and you can actually try to predict if a customer is going to click on that digital advertising. And then it could be an email that we want to classify it as a spam or not. It could be an image or LiDAR info to get the position of the cars that we use today in self-driving car world. And if you're in healthcare, you can easily look at the MRI image. You can see the diagnosis, yes or no, or the size of the diagnosis, diagnostic nodule could be an application in healthcare, or in speech. Your output is demanded to be a text script, which is an application in speech recognition. So the key portion in here, in order to apply machine learning algorithms, I need numerical values in this matrix. But if you look, for example, an email is text, like how I'm going to relate the numbers to text, or how am I going to relate an image to text? So that is where the game started. We need to transform this unstructured data, image, text, audio, into a numerical representation that we can learn from their supervised column to be able to predict something. Speaking of that, I like to classify what can we do with that matrix. First, as I said, supervised learning, a model to determine the relationship between input and the output variables. This is supervised learning. I'm learning labels, trying to predict unseen data after sufficient learning from here. We call it training phase. There is unsupervised learning. Model find patterns from unlabeled data, meaning that I don't have enough labels or non-labels. Let's say you want to make a fraud detection use case in your companies, but in your historical data, you were not able to label any transaction as fraud before. Then all I need to do is work in this space, not this space. This is unsupervised. It's not getting supervised from this column. So what can I do with these features? Oh, actually, if you look around, there are a lot of use cases that we can only utilize the features. Let's say I have customers. I don't want to predict anything about my customers, but I want to segment them. I want to cluster them. I want to actually find similarities between them. I don't need to necessarily predict something, but I can actually extract some insight based on the similarity in my data. That's the unsupervised learning. All right. The third one is reinforcement learning, a model that improves upon itself in new situations using a trial and error method, very similar to humans learn. Let me go back and try to connect some dots about AI and all these things. So think about a baby. In the supervised learning, basically think about this matrix as a baby. We are saying that, hey, look, these are the features. Learn from these labels and see, let's say 1,000, 5,000, 100,000 observations in here. Try to learn and apply this knowledge on something new when you predict. It's how we actually treat our babies. If you eat a slice of orange, how to eat a slice of apple, how to eat a slice of peach, let's say 100 times, baby is gonna learn next time when you give a slice of banana, baby is gonna be able to eat it because it learned from the previous experience. That is supervised learning. However, in real world, and the human brain doesn't work that way at all situations. For example, we cannot teach a baby how to walk, although we show all the instructions, all the way, all the uh, different styles of walking. The baby needs some exploration, trial and error to be successfully walking at the first place. Like, for example, me, even though you show me all the data, you give me all the instructions, I may not be able to play golf very, very successful in the beginning. I cannot make that swing. I just need my time to do trial and error. Like, I need to actually use my time to be able to improve and improve and improve regardless of the instructions. So there are two things in AI world. One can be learned through supervision like this. Hey, just show me some examples. I'm going to figure out and I'm going to predict. Or just tell me what to do and give me enough resource and time. I will learn with trial and error. And every time I'm close to doing good, you give me reward. If I'm not doing well, you give me a punishment or penalty so that I will improve, make sure that I'm not going to do. So human learning AI is using today. The caveat on this was, well, if it's supervised learning, I'm not fully utilizing my data, meaning that you have billions of documents, you have billions, you have gazillion number of data points, which is not including the proper annotation or label. Because I can only use supervised learning to the extent of the number of my labels in here. And it only gives me, if I have, let's say, 100 million transactions, and if I only label the last 5 years, I can only train a model only with last 5 years data, and the remaining is untapped. And since data is growing exponentially, we need to come up with a new methodology to learn from data itself, but not from here. That actually took us to generative AI's foundation, self-supervised learning, meaning that model learns from unlabeled data by predicting certain aspects of the data itself, enabling it to later apply to this knowledge to other tasks. Let me stop sharing, and I want to make a discussion with you. All the machine learning models are programmed. Hey, these are the features, attributes, variables, and this is the output. Learn from them based on how many you give to them. If you don't have those labels, let's say you don't you have an email spam classification use case, you were able to label 1,000 of them, and you want machine learning to learn from it and predict the upcoming emails if it's a. You were only labeled 1,000 of them. There are millions of emails in your cloud store. Without requiring any label, what can I learn from these emails? Like, think about it. Again, we are trying to ingest as much as data and information without actually predicting something, without actually learning to eat an apple. Think about, you are giving a human 1,000 books, but you're not given any task. You don't ask them to write a summary of each book or create some character analysis, nothing. You just want the baby to read, or a person read this 1,000 books. But there is a condition. You have unlimited time and resources to read a book again and again and again and again to make sure that you understand everything. In that situation, what we do is, well, do I really need this? Do I really need this labels? No. I will just read through the book, and I will play games. I will mask some of the words and I will try to predict it. I will finish a sentence. If it's my fifth time reading that book, maybe I will remember what was the upcoming sentence. So then I will register everything I learn into my brain. Actually, I'm not registering the semantics of the words, but I'm registering the association of the words. Every time I read, I remember if I see San Francisco is coming afterward because the story is being held on West Coast in California. I will remember the associations of the words. And when I read enough book, now I have the baby's memory capacity. Then I can teach what I can do with that book reading learning. That is the essence. Let me visualize it more for you, but all together, everything brought to Gen AI, self-supervised learning. Self-supervised means you just read by yourself without getting any supervision from an output label. I'll come to that. I will visually explain you a little bit more, but I just want to show you how the human brain works for a second. Can you show me the anomaly? Which one is the anomaly in this matrix?
Twenty-six.
Tanmay, why? Why do you think it's 26?
Because all numbers are divisible by 4 and
Not
26 is
divisible by
accept
4.
that.
Okay, why not 96? Because it's the maximum number.
I think 26 is
96
the
is
only number which
divisible
is
by
not
4.
divisible by 4.
What is it?
26 is the only number which is not divisible by
But I
4.
didn't but I didn't tell you which one is not divisible by 4. I just asked you find the anomaly.
Yeah, 96, which can be call it as an outlier.
But think about it. In 2 seconds, your brain thought about all the rules that you learn in the school, some other techniques, and suddenly you came up with this rule, this divisible by 4, and you're thinking that that should be the answer, although I didn't give you a rule. Do you think how did we come up with? That's fascinating. Human brain, right, Tanmay? It's a 3 seconds. But
Yes.
it's all the training that we have got so far because our brain works that way. We played a lot of puzzles, we played a lot of games, and we automatically understand divisible by some numbers could lead to some
Anomaly.
anomalies. And
Yeah.
we actually demonstrated an output of self-learning, self-supervised learning. Nobody
Yes.
told us the rule, but our brain came up with the most frequent one that our brain is very familiar with. That is what we are actually trying to achieve with generative AI. To read all those books, like we did, we solve all the puzzles in the elementary school, junior high, high school. Now our brain knows how to react without actually waiting for a rule. That is what we are trying to achieve with generative AI. Okay, without any given rule, we expect based on what it read from those books to respond. Perfect. But there is one caveat. If I ask you to learn everything on the web available, how would you do it? Well, let me specify a little bit more. There are over 50 billion pages of information on the internet today. And someone asks you to read and understand all of it. How would you do it?
It's obviously structured.
Yes, first, that's great. I would categorize them, right? These are the sports-related articles. These are politics-related, or this is entertainment. So I can make a high-level structure in my brain to organize what am I going to read. Perfect. Second, storage. Are you going to be able to remember everything you read with our brain?
It's not possible. I don't think so.
Yes, we have the memory issue, right? Well, I'm not telling you not to read further, but read as much as you can actually digest and ingest. The
Most
third is the
importantly, it
time.
is
Yeah, go ahead.
that's what I'm about to say. It's time. It is the most important thing to begin.
Time and storage.
Yes.
Time is important. Like, think about how long does it take to read one page of paper for a human? Let's say a minute. If I'm talking about 5 billion pages, if we spend almost 50 seconds a minute to read, it's going to correspond to 5 billion hours. If I just do read 8 hours in a day, 5 days in a week, then it corresponds to 255,000 human years, which is not possible to consume this information as a human, only time dimension restriction. Forget about the memory. However, we have the foundational models which can do this in a few months. Why? Because we have GPUs, processors. We just want it to read. We don't want to be it's smart as much as a human being. We just want it to consume, read the Shakespeare book a million times. It's not gonna be a deal. But I don't have time to do it or memory. But the foundation model has it. Foundation models are not as smart as human brain yet. Like, do you remember what was the parameters of GPT-4? Can someone check online? You know, last year everyone was saying that, oh, this is 100 billion parameter language model. I'll tell you what does it mean. Let's say the largest foundational model today, let's say 100 billion parameters. Okay? Do you know how many neurons in our brain we have? Yes, no?
I found about 100 billion.
Yes. So a parameters of a foundational model 100 billion, and it says in our brain has 100 billion neurons, meaning that this foundational model parameter means the number of these connections. We call them weight, and these are the neurons. And the best language model as of today has almost the same number of neurons of human brain. And think about how many different connections human brain can establish with 100 billion neurons versus the large language model has only 100 billion connections. So we are not even halfway there. We have that advantage. We can visualize, we can observe, we can think quickly, for example, that anomaly detection. However, this large language models has the capacity to read further and keep in the memory, which is not as smart as human brain yet, but it has no time restriction and the memory. Best piece. They are not make creative or smartest decisions as human can detect, like, for example, anomaly 26 divisible by 4. However, it has some capacity, although at not level of the human, to figure out a couple of things and respond. So that's where we are, 2024, first week. Then what is coming? First of all, in order to create a smart AI system as equal to human brain still has a long way, because we have visual memory as well. The visual memory is not integrated. This is only text. How did they do it? They compile and pile all these different data sets: PubMed, Central, Law, Wikipedia, GitHub, Med, Stack Exchange, all these things together, brought a lot of GPUs, read all of them. 2 months. After reading 2 months, we ask these foundational models to check how did the reading well. How did the reading go? Well, we expect them to actually predict the next token, which is the word. For example, the perfect start to my day is a bagel with cream cheese. So after reading 100 times of these, bagel with cream cheese became a thing. So it is autocomplete the rest. Like, think about a human brain right now. If I ask you what happens in Vegas, how would you complete the sentence?
Stays in Vegas.
Stays in Vegas. How do we know this? Because we have seen this gazillions of times. It's in our brain. Now I can predict what's gonna come next. That's the same thing these language models are doing. They read a lot and they predict what's gonna come next. Okay. How they make sure they understand well? While they're reading, they're trying to mask some of the words and try to predict. If they can predict, they don't need to read more. If they don't, read one more time, read one more time, read one more time. They play games while reading to make sure that they remember everything from the book. But the thing is that it doesn't store what they read in a database. It just remember the associations of the words. For example, when you type the quick brown fox, then Google auto-completes, jumps over the lazy dog, right? Do you know what it is? It is the phrase that all the unique alphabetic characters included in English in one sentence. That's why it is frequently typed. That's why it doesn't remember this sentence is actually serving that need, but it remembers usually quick brown fox, jumps comes after that, over comes after that, lazy dog comes after that, because we have seen it a lot, like stays in Vegas situation. Again, this is important. People are not knowledgeable about this. This is not a database to return this sentence. This is an association information just to predict what's gonna come next. So GPTs started with GPT-1, GPT-2, 3, 4, right now the Turbo. All it does is, based on the given previous token, predict the next one. Let's see. Okay. So for example, I was is a higher probability. Next, it could be there, in, glad, happy, confused. Let's say happy. Then how am I gonna choose what to come? Because of the question, because of the context. In here, there is an important difference. There are a lot of options to predict what's gonna come next. So how are we gonna pick what is the right thing to see what's gonna come after? Context. What is the context before and after sentence in the paragraph? And we were able to achieve this technology in 2018. We solved, I mean, when I say we feel problem when you read something, we were forgetting what it was. We didn't have enough memory. Then we figured out a way to get the summary only in. And this is a use case where we apply a lot in our lives. And let me stop sharing and talk to you again to make it more fun. Think about your translator, live translator, and I'm a very important celebrity who speaks French, and I will talk in a press conference. You will listen what I say, and you will translate what I'm saying to the audience in English. And I start talking. I talk in a minute. As a translator, can you remember exact word that I said during this 1 minute and translate it? Or how would your brain works?
I think as a translator, the brain, you would take a little bit of what you understand, summarize it, paraphrase it, and then translate it, because it's very hard to verbatim.
Exactly. We just highlight the important pieces in each sentence, then you actually return back while you translate, right? It's the same with the language model. In order to predict what's gonna come next, I cannot remember everything before and after, but I can remember a little bit of gist of everything around me, which could be sufficient for me to predict what's gonna come next. That changed the game. Now I can keep the information surrounding in my memory, and I can predict the next word. I already read tons of documents. I know the associations, so I can solve a lot of problems. That's what the foundational models today, you frequently hear LLMs do. And with this, I can do text generation, I can do question and answering, I can do summarization, I can do paraphrasing, code generation, a lot of things. You can do these things, but how are you gonna make it act like a human brain? In the human brain, think about a baby. We just gave the baby 1,000 books to read. And we didn't ask the baby to do anything with that information. We just created the foundation. That's why we call them foundation model. On top of what baby read, if you show that, hey, like for example, this is a 1-page document, this is a summary, and I created 100 samples for you. Look, it's a supervised learning. This is text, this is summary. This is text, this is summary. Based on your foundation, learn the skill. And after you read 100 books, now I'm going to give you one more book, and then you will create a summary for me. Baby is going to say yes, because baby already learned the associations between words. All you need to do is introducing a task. Hey, if I ask you what is the capital of Denmark, baby cannot answer. But it read the book about this geography and the stuff. If you show the baby, hey, when they ask the capital of France, that's Paris. When it's the capital of England, this is London. It's the capital of Austria, it's Vienna. Then the baby understands, oh, I read this. I got what is the capital. Now let me return that information, and the capital of Denmark is Copenhagen. Because that foundational model got that information. All the baby needs a guidance. But this guidance may not be straightforward. For example, here, look at the left one. Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? Well, 5 tennis balls, 2 more cans, and each can has 3. 6 plus 5, it's 11, right? And I tell the baby, without explaining how did I come up with 11, it's 11. Versus I explain the baby, look, Roger started with 5 balls and he bought 2 cans and each can is 3. So first let me calculate the total number of balls coming from 2 cans. It's 6. Then I need to add that 6 to the existing number that I get 11. If you teach like this, baby is gonna respond to the next question correctly. If you don't teach it like this, then it's going to fail in the next question. This is called chain of thought reasoning, that if you want to explain, if you want to teach something to baby, you need to give explicit steps. If you just say this is 11, baby may not learn enough. So with this technique, we can teach a lot of things to these foundational models, like mathematical reasoning, code generation. All we need to be careful to make it in chains, step by step. Isn't this the same while we are learning? If someone gives me the answer, it sometimes is not helpful. I need explanation. How did you come up with that answer so I can solve the next problem by myself? So we are in a place right now. We read all those things. We know all the associations of the words. Now we are learning skills. Like I did summation. I did summarization. I'm solving a mathematical problem. Basically, you can teach a lot of things that human brain can do to these foundational models. So I will pause for a second. And if you have any comments, we can discuss.
Yeah, and I just want to interject real quick. If you do have a question, you could always feel free to use the raise the hand feature in Zoom. Oh, right there, Matt, Matt Simmers. And then you can just go ahead and unmute yourself and ask the question or comment.
Thank you. One question I wrote down was we make decisions often because of our past experiences, which we aren't always cognizant of. Like if a model reads an article, for example, with some new ideas, that influences the association of the words. Doesn't that influence what a coherent path is through this language space? Wouldn't that be independent of explicit memory? We were talking earlier just about how like storage is a huge issue.
Yes, and I will explain it, Matt. This is the most common problem in business right now. How we are going to incorporate the local documents into this foundational model knowledge. Am I going to right place? So let's
Sorry,
say,
yes, I think so. Oh, sorry, I'll stop.
yeah, let's come up to this after that one. Before going to that one, I want us to think this foundation model is a electricity, general purpose. And you will decide what you can do with this electricity. You can run an engine, you can do other things. It's basically everything we teach is the application of electricity. Now ChatGPT can write poems, summarize my documents, answer my questions, solve my homework problems, calculations, right? Like it's been all taught. How? There are Stack Exchange solutions of some codes. It learns from it. There are a lot of forums and information how to approach calculus problem. It learned from it. So it is like electricity have different usages. I want us to look at from that way. And when we look at the parameter size, if it says small language model like 8 billion parameters, it can do question answering, arithmetic, language understanding. But it's over 5 billion parameters, it can do all these skills. And it's growing. Now, I want to come to Matt's point. What is the usage responsibility in today's business world? Here is the answer, Matt. So, couple of things. Matt, please correct me if I understood your question well, but let me explain based on how I perceived it. So let's say Alberto read 1,000 books. That's the foundational model, right? This is, where is it? This is, you read 1,000 books in your life. Now you join to Data Science Institute. Now I gave you 3 more books to read. Okay, 1,000 books plus 3 more books. Now I'm going to ask you a question, and you're going to answer that question based on the information in all these 1,000 plus 3 books. However, there is a caveat there. Based on what you read before, this 3 new book may include confounding information. Let me put it this way. What is the capital of Switzerland?
Are you asking me?
To asking everyone.
Oh,
Capital of Switzerland.
Bern?
Zurich.
Bern.
Or no?
Ben says Zurich. Shreya says Bern. Which one is correct? Doesn't matter. That's what I wanted to hear. Because we read a lot about Switzerland, and we usually hear the Zurich as the most popular city, and it automatically ingrained in our brains as the capital. However, with this new 3 books, I'm telling you, the capital of Switzerland is Bern. What you read is wrong.
Okay, so I think I understand, like, so by nature, new information is relatively sparse compared to old information, which it's read. So it
Correct.
would be more likely to answer with the old information. And I think that's the purpose of, I see retrieval augmented generation. It's like fact retrieval.
But it's gonna be in your control. Like, do you want to answer with the new information, or you want to answer with the old information, or you want to blend these two to come up with a new idea and new, like, fairly new answer? There are 3 ways you can go. Okay, you can say, look, I don't trust this new information. What I know, I read a lot, and Zurich is the way to go. Or you can say, look, this is peculiar to this, and it is a sparse information. I believe in that. Bern is the capital. Or you can say, although I read from a lot of places and it remained in my mind that Zurich is the capital, however, the most recent information that I ingested tells Bern. So you can provide these 2 things. Although Bern is the capital, Zurich is a very popular city. So the problem in today's industry, how we are going to merge these 2 information, what the large language model knows, how my local company data is going to blend in, marry.
Has anybody tried biasing recency when training the models for the associations?
Yes, we're going to come to that point. In the early, for example, in our program, in the research capstone, we made an experiment. How this blending works, especially when there is confounding information. It requires a lot of resources at the companies, because this large language model training can cost millions of dollars for the OpenAI and Microsoft and the other people. And blending new information is a little bit cheaper. However, it is very important to show where this new information should go, because that information may be in a lot of different places. That's why it may get lost and it may not blend very well. and it's very expensive for the companies. That's why the companies started using prompt engineering and retrieval augmented generation, meaning that, look, when I ask you what is the capital of the Switzerland, just answer as Bern. Forget about what you know before. I'm telling you this is the correct. That's the one way, piece by piece. Second is, this is the new books, and these are what you have read. I don't want them to blend. When I ask a question, I will explicitly tell you, go use your own knowledge or go use the new books that you read. So by doing it, I will eliminate this mistakes I do through blending. That's the retrieval augmented generation. Hey, I ask you what is the capital of Bern. I just gave you 3 books to answer it. Don't forget about what you knew before. Just go grab that information and answer. That's most companies do. But if the new information is not 3 books, it's also 1,000 books, that I need fine tuning and I need to blend them with the oldest information. Yes, Sebastian.
Hey, Professor. So I had a question about the neural networks that you mentioned earlier.
Yeah.
And specifically, I'm curious if in training some of these large, these LLMs, companies like Google and such, they used Bayesian inference, and if that would save time.
There is a lot of methodologies. It really doesn't matter in terms of training time. It's the data structure we are using. Transformers is the key. As long as you have the feed-forward neural networks in the transformers, which you need to decode and encode, then you can pair them up and create that memory like we gave in the translation example. It is going to be sufficient. Well, you can actually expedite this learning by using Bayesian inference or other recurrent neural network techniques. However, those are mostly the operational, not the performance-based.
Got it.
The people are trying to reduce the cost right now. It's millions of dollars to train, and even by sacrificing from some performance to make it cheaper. So that is the dilemma there. So I see a question on the chat. Computer science on masters in data science. That's good. And Daniel can respond that. Let me finish the generative AI conversation. Okay. So this is what we are going to follow in business. Like accuracy is gonna be perfect if you retrain everything from with your internal company data, but it's costly, right? The cost goes up. But for the cheaper solutions, we can use retrieval augmented generation to answer the questions based on the internal company documents. That's where we are. Most of the companies in Chicago that I'm consulting affiliated, everything is around retrieval augmented generation. However, some of our colleagues, one of my friends from high school actually in the Bloomberg, they trained Bloomberg GPT from scratch. 50 billion parameter. They spend millions of dollars. But with a little bit of adaptive fine tuning, you can get the same performance they did. So there is still ongoing research based on your data size, which way you should go to blend this information. Okay. Yep. Bloomberg GPT, 50 billion parameter. And some use cases we utilize is improve customer experience, productivity of knowledge workers, market customer sentiment, drive product innovation, automate business processes, and of course, all of this come with a risk. And Daniel, if you don't mind, I want to answer that question, computer science versus applied data science or data science program. The main difference is today, We do research. I'm an associate professor, PhD from Northwestern and the University of Illinois Urbana-Champaign. I grew up in an academic environment, purely theoretical. But in the AI field, it is highly dependent on the application in real world because it's not quantum physics that we just publish papers nobody reads other than our little world. We just want to publish something. I don't want still everyone to read my paper, but I want that work is being utilized in United Airlines or in Amazon or Google, like whatever. Because it is integrated with marketing, finance, strategy, accounting. Any business unit can use AI on their daily operations. To me, it was very inspiring to reduce the load of research, publishing papers only for the academic audience versus publish white papers, present in practical conferences, and see how they are functioning in actual world. So most of the applied data science program faculty and professors, we are not only giving the mathematical foundation of the concepts, also know how did it work in real life? What were the problems? If you develop a model and publish a paper, it doesn't mean that it's going to create a value in your company because it needs to be precisely deployed. It has to be responsible. It has to be create value creation. Like it has to compensate all the effort. There are a lot of metrics, business metrics, model metrics, data metrics. So that's why we want to bring that part into the program as well, to be able to share our experiences, observations, how these things abstractively we are teaching you is actually working in real business environment. That is the major difference of applied program versus a computer science program. Does that make sense? Okay. There are a lot of vulnerability around it. We cannot just plug it in and use in our companies. Some of them are very emerging, and we are on the cusp of designing the best countermeasures of them. I'll just give you a couple of things. Generating targeted text to mislead people, generating realistic images to con the people, summarizing and paraphrasing could eliminate some emotions and meaning, but most importantly, misleading the people. For example, a person just shared this on Twitter to say there is a explosion near the Pentagon, but it's the AI generated image just create noise and panic. Although it looks like very similar to Pentagon, you can see the difference. Some of the fans are missing in the image that from the real. Or hallucination is another problem. A New York-based lawyer who used ChatGPT to prepare his filing for a legal case, unfortunately, text generated by ChatGPT included 6 cases that were entirely fabricated. And then accused lawyer was unaware that ChatGPT is not a search tool, but a generative language processing tool. That's why I was trying to tell you it's not a database. It is just a language processing tool, which is specifically trying to predict next word. And grounding is the most important business issue. We cannot let the generative AI models to give their best response, which is different than traditional machine learning we have learned. Alignment means if there is a toxic or profanity You need to guardrail. If I ask you how to make a bomb, you cannot respond me. Although you're right, that's not correct. That's the difference. Because previously in AI and machine learning, we were only measuring the performance. If it's predicting the correct, it was good. We can adopt it. But in here, although it gives me instructions how to make a bomb, I cannot accept it. So there has to be an alignment between the user and employer of these models. There are a lot of spear phishing, dissemination of deep fakes, a lot of examples. You should be conscious not to get caught. A lot of research is going to identify how we are going to separate the generic or Gen AI generated information versus it's actually coming from an actual human being is a big research right now. There are some countermeasures. For example, we do watermarking in some of the AI generated content to make sure this is coming from a language model or Gen AI model versus this is written by a human. We do code analysis, multimodal analysis, human AI collaboration is the key. So there are a lot of defenses that we can use. I just want to wrap it up with a funny part that our photographer in our wedding told us, hey, these are the previews. There's a watermark here. If you want to purchase them, you need to pay X amount of dollars. So we're going to remove the watermark. And I told him that as the data science community, it will take us 3 minutes to remove this watermark. But as an ethical, good person, I want to pay for this, but generate a new technique that cannot be easily removed. And we work with this photographer to embed the watermark in a way that none of the generative AI or machine learning tools can actually delete it, so he can continue protect his IP rights on the taken pictures. So there are a lot of countermeasures happening around the watermarking content and not easily getting rid of it. But overall, it's a very nascent field. It's growing tremendously. A lot of things being published every day. We are trying to be up to date. We share all this information with our students as much as we can. And we create new course. We first generated the research part in our applied data science program, for example, not only teaching the applied version, but also researching. So we are going from all the directions to be able to make a one-stop shop, great learning experience within Data Science Institute. That was the end of my presentation.
Thank you so much, Professor. And I want to thank you again for taking the time, especially with the start of the new year. This time is always busy for everyone trying to get the engines back up and running. I know I've been seeing a lot of questions coming in, and we won't have time to answer them all because we're coming up on the hour. So I am going to throw my email address, my personal email address, into the chat right now. And so as questions come up, feel free you could email me directly and then I can go ahead and answer those. But I want to be, respectful of everyone's time. This was designated for about an hour. And again, thank you to Professor Uku and thank you to all of you for joining. I know there's prospective students, current students in the program who attended today, as well as those that, are just truly interested in how data science is impacting multiple different industries at this point in time.